All right, today we're going to be covering the 7-3 section of our notes, understanding experimental probability. Now, 7-2 was covering theoretical probability, so experimental probability is the second part of that. So let's look at example 1. We're going to compare theoretical and experimental probabilities. It says Talia and Yoshi playing for 1 out of 8, or 12.5%, and we get that by taking 1 divided by 8, of the players winning a prize. So this game, our little pointer on the right, they expect that 1 out of every 8 people that spins the wheel, or 12.5% of players, will win a prize. During the school fair, they keep track of the number of total players and winners and recorded the data in the table below. So all of the people that played the game, they recorded how many people won the game and how many total players there were. And what they expected to happen was that 12.5% of the total would win the game. So our question says, how does the actual number of winners, so the actual number of winners, compare to the expected number of winners? Okay, so that's what we want to find. So let's go ahead and look at this table. It says from 10 a.m. to noon, there were 213 total players and 22 winners. From noon to 2, 262 total players and 36 winners. And what they did here at the bottom was they had a total of 475 players and 58 winners. Now, based on what they have up here, they expect that to be about 12.5% of people, or 1 out of 8. So we want to determine the relative frequency of winners. So that's a big word. Okay? The relative frequency is the ratio of the number of times an event occurs to the total number of trials. So ratio of the number of times an event occurs to the total number of trials. So we're going to see the same little box over here to the right now. Okay? We've got 10 a.m. to noon, noon to 2. And what we have now is we are finding the relative frequency. So all we're doing, we're going to make a ratio. And what we're going to do, we're going to put the number of winners over the total number of people, right? Number of winners over the total amount of people for each one. So in this first one, we get about 10.3%. Use a different color there. We get about 10.3%. From noon to 2, we get 13.7. And when we put them together, we have our total 58 winners, 475 total players. We get 12.2%. Now notice right away, we see the difference here. Because right here at the top, we had 12.5%. That's what we expected, but what really happened? 12.2. So they were close, but they were not the same. So step 2, the relative frequency of an event. So what we found out here, this percent, by taking the number of winners, dividing it by the total, right? We can also call that the experimental probability, right? Experimental, because we did experiments, we did trials, right? They played the thing, they spun the spinner. That's an experiment. And we're going to compare that experimental probability to the theoretical probability. So here's a good vocab here. The experimental probability is based on actual results of an experiment. Okay, so this is what actually happens. While theoretical probability is based on calculated results. So one of the things I like to say is this next line. In other words, theoretical probability is what should happen, and experimental probability is what did happen, right? In this spinner, they expected 12.5% of winners. That's what should have happened, but is that what did happen? No, right? They expected 12.5%, but what did happen? 12.2, right? Theoretical probability is what should happen. Experimental is what did. So we're going to put those right next together here. So the theoretical probability, so the probability of landing on a red space was 1 out of 8, or 12.5%. Okay, that's what should have happened. Okay, now the experimental probability was 50 out of 475. Where are they getting those numbers from? Right here, 58 winners out of 475 players. And what did they get then? They did 12.2%. So not quite the same. They're similar, they're very close, but they're not exactly the same. So we can say in the previous lesson, this 7-2, they expected about 63 out of 500 players based on the theoretical probability. Okay? But based on the data, there are actually 58 winners out of 475. So let's go back to our question. How does the actual number of winners compare to the expected number? So how does the experimental probability compare to the theoretical probability? Well, here's a good way of putting it right here. The experimental probability is slightly lower than the theoretical probability, right? 12.2 is less than 12.5, right? And if I wanted to write that here, maybe I'd write it something like this. 12.2, okay, is less than 12.5. The experimental is less than the theoretical probability. There were slightly fewer winners than expected, right? So once again, this is a difference between what should happen and what did happen. What should have happened was this, 12.5% should have won the game. What did happen? 12.2%. So experimental probability, theoretical probability. Okay, let's go to the next page. Okay, example 2. Use experimental probability to make predictions. It says Joaquin also kept track of players and winners for his game during the fair. Based on the results shown in the table, how many winners should he expect if 300 people play his game? So what we're going to do, we're going to use the data in the table, see how many people should win if 300 people play. So we're going to use the experimental probability to make a prediction. Okay, the experimental, what did happen. So we're going to use proportional reasoning. We're going to set up and solve a proportion. Okay, so what we do first, we look at our table. 28 out of 174, 43 out of 243. But what we want is the total. We want this. We want the number of winners here. We're going to put that over the total, which is what we have here. 71 over 416. So our experimental probability was 17.1. And we're going to use that to set up a proportion. So what do we got? Our first ratio, 71 over 146, is equal to W over 300. Right? This is what did happen in our experiment. And what we want to know is what, instead of 416 people playing the game, what if 300 people played the game? Okay, and with any proportion, we know we have to cross, multiply, and divide. Right, we're going to take 71 times 300, 416 times W. So that's what we're going to see on this next line. Put this up here. We have 71 times 300, 416 times W. Right, we multiply those to get the cross products. 21,300 equals 416W. Well, we know we always want to divide by the number that's next to the variable or being multiplied by the variable. So we're going to have this. We're going to divide by 416 on both sides. And what we're going to get is a expected winners out of 300. And what do we get? 51.2. So we would say there's going to be 51 winners if 300 people play the game. And that's what we should have written right here. Joaquin should expect about 51 winners out of 300 players based on the experimental probability. So 51 out of 300 based on experimental probability. And why is that experimental? Because we used the data. All right, what did happen to make a prediction? What did happen to make a prediction? Okay, let's look at example 3. It says, explain the differences between theoretical and experimental probability. Remember, from the first example, theoretical probability is what should happen. Experimental is what did happen. So it says Amir and Marvin each flip a coin 50 times and record the result of each flip. The tables show their results. So let's look at the table. It says Amir flipped the penny 50 times, 26 heads, 24 tails. Marvin, 30 heads, 20 tails. So let's look at this first. Based on theoretical probability, what are the expected results of 50 coin flips? Now, what we should all know is that a coin has two sides, heads and tails. And there's a 50-50 chance, or 1 out of 2, to get either side. Okay, heads or tails or both. Okay, 2 possible outcomes. And both outcomes are equally likely. Why are they equally likely? Because it's a 1 out of 2 chance. Okay, so that's what we know is our theoretical probability, is 1/2, 1 out of 2, or 50%. And I'll put that right here, 50%. Okay. Okay. B, why might their results be different from the expected results based on the table? Now, if this was the case, using their theoretical probability, each person should have got 25 and 25, because half of 50 is 25. But we notice that's not the case. And I think we all are aware that, well, just because there's a 50% chance doesn't mean it's going to happen. You're not going to get 25 heads and 25 tails, right? So the theoretical probability can be used to estimate results, but does not guarantee results. And that's important. Just because 50% of the times you should land on heads doesn't mean that it's going to happen exactly 50% of the times. Now, this next sentence is important. The more times they flip their coins, the more likely it is their results will be closer to the theoretical probability. Okay? So the more times you do something, the more experiments, the more trials you perform, the closer your probability is going to get to that theoretical probability. So let's say they flipped 100 times. Okay, that get much closer than what it is now. Okay, and that's how these two things are related. Okay, so experimental probability is what did happen, right? That's what this is. Theoretical probability, that's what that is, right? Theoretical is 1 out of 2 or 50%. Well, experimental, it's not 50%, but it's close. Okay, let's go look at the next page. A little review here. So the relative frequency, which can also be called the experimental probability, the little arrow, is based on actual results. So that's important. I'm going to highlight that again and again. Based on actual results of an experiment, while theoretical probability is based on calculated results from the knowledge of possible outcomes. Okay, so that's important. If you need a definition, there you go. That's good. Experimental, based on actual results. Theoretical, based on calculated results. These things can be close, but they're rarely ever the same, as we saw in our little coin example. So how do we find experimental probability? We take the number of times something happens, winners, how many times you land on blue, okay? And you put that over the total number of times something happened, okay? So in our case, we talked about spinners, how many times they land on red, how many times they spin it, okay? So this experimental probability tends to get closer to the theoretical probability the more trials are conducted. So the more times you do something, the closer these things are going to get.